I guess what I'm suggesting is that locally is often useful. We don't care. We can't. We have confidence that the local value will be finalized. And unless
But we don't have this confidence, right?
we have this confidence.
You deploy something, but and propose, but you don't know. Still, you don't know.
Well, there's only certain conditions where we care. Okay.
I mean, we care that is received by the validator, right?
Right. We're dealing with eventual consistency. We're dealing with a lot of things. Where we care is, like you said, in the double spend type situation, where we both read a channel and, in essence, do some transaction, even if it's just adding one to it, that has to be globally agreed to. Okay, that's not often the case. Right, we don't care what order anything happens in. It's only in certain cases where it really matters. And, just because we have in our local namespace, we have some degree of ordering or reads and writes that sequentialize the process. Very often, those don't affect the global world. They only affect the world within our namespace.
Okay. Yeah, I see what you mean.
Talking about are you talking about? So I just jumped in, Isaac, just like you.
Oh, okay, cool.
You're talking about getting consensus over stuff that matters locally or in some small sphere, but doesn't really need to have global consensus over it.
So we started from the node testing.
Oh, cool.
What does it mean? I'm really interested to hear your opinion. What does it mean if you're listening for a name? So you're proposing something. You have your deploy, and you propose.
I wonder if Chris can join. I'll ping him.
Yeah, that would be useful.
Because he was saying, I was, bringing up this problem, and he was saying, no, that's not the way it works. And I'd really like to hear what he has in mind.
Yeah, so Tomislav, keep stating the problem for us. So I deploy some code that has a 4 in it, so I'm listening on some name.
Yeah, and what is the point in time when you can really listen on that name and get the value? Is it the right time when you ask this node, this validator, or when you achieve consensus about this about your deploy? Because for me, if validator gives me a value that is not finalized in the whole network, in this network that I care about, that I may deploy, this value is temporary. Maybe it can possibly be finalized, but I'm not sure. I cannot act on this value. So.
Yeah, you can't act. That's a really good question. So I guess first, there's really even 2 finalizations that are relevant. There's the finalization where your deploy got accepted into the chain, and then separately wherever a COM event happened.
Oh, but Kevin has this COM event directly inside the deploy. He immediately put something on the channel and automatically read. But this deploy is not finalized. So you're asking for a name, and for me, this is not really clear.
Well, in that case, that whole block will be finalized all at once. So like so I've deployed some code that listens on a name. The name I'm listening on was already there in the tuple space. It's not like a new name.
So you are creating this new name when you're in your deploy. But when you say it is finalized,
Yeah.
it is finalized after some time that when this block is propagated to the network. Right?
Yeah, and enough Casper stuff happens.
Yeah.
Yeah, well, it's
So
not finalized. When you make the new name, you do something, you write something to it, and then you read from it. Okay, and this gets deployed, and when it's deployed, what you write to that channel, you can read from your application. Okay, it's not
yeah.
right. So the issue, my issue was sort of what is this feature that they were talking about being able to read the finalized value. It's like, I don't want to read this channel yet. I want to read it after it's been.
I think you can send the same data to two different validators. So after some time, your application will get different data for the same thing. When you ask the third validator. So in that sense, I think if you want to work with the blockchain, you want to get consistent data for this channel, which is the real data, not some unfinalized data.
Oh no, am I supposed to be are we supposed to be having the governance meeting now?
No, I'm a little early. I was just tuning in, but you can continue. I just tuned in so that if I have questions, I could kind of ping you. But
it's good to see you back, bro.
Hey, Tomislav, how are you? It has been a long time.
Yeah. How are you? I have many news,
Yeah.
We should talk again.
I think Rao can be really valuable in helping us with governance. And hopefully some of you other guys will jump in too.
Nice to meet you, Rao. Hello.
Yeah, nice meeting you, Joshy.
We're taking over the co-op.
Isaac.
Nice to meet you, Rao.
Yeah, so I had invited Isaac because he had a interesting visualization. Well, you should describe it.
Yeah, all right. I'm I don't know how to present information like this in this kind of forum, but I'll do my best. So sometimes when I'm thinking about rholang and specifically when I'm just coding a bunch of stuff in K, I try to think of pictures to kind of guide me or really just to distract me sometimes. But the picture I started thinking about yesterday, let me take a step back. So I have a background in complex analysis, and maybe some of you know this, but there's the complex plane. So it's, a two-dimensional number system essentially can be mapped in a very particular way called conformally to the surface of a sphere. And that's really interesting because when you're in a plane, it looks like you can go in many different directions, right? Like any, way emanating from the origin, for example. And it seems like you would end up at a different point potentially if you were to start traveling just along like a ray from the origin. But basically what that conformal mapping to the sphere from the complex plane tells us is no matter which direction you travel, you'll ultimately end up at the same point, which is the point at infinity. And that's like the north pole of this particular sphere. So you can map the plane to the sphere in such a way that the origin goes to the south pole, for example. The unit circle, so the circle with radius 1 centered at the origin, goes to the equator. everything inside that circle goes to the southern hemisphere and everything outside that circle goes to the northern hemisphere. And then maybe from that visualization, it sort of makes sense that anything outside that circle and anything inside that circle, we could flip them fairly easily just by reflecting with respect to the equator. And there's a very simple mapping that does that for you. It's just the reciprocal mapping. Like if I were to take a complex number and then look at 1 over that complex number, that is the reflection with respect to the unit circle.
Is that changes if you make the equator something other than 1, right? Like if you
Yeah,
split it or something. Okay.
absolutely. Yeah. So I was going to say, and you can change the origin to whatever point. So you can do a translation, and you can also expand the radius of that circle, but the principle is still the same. So for whatever reason, I was thinking about that in relation to rholang or rhocalc. Either way, I think it works. And so basically what I was thinking was we sort of have an origin in rhocalc, which is the stopped process. So using the stopped process as the origin, then I was thinking, well, what would the point at infinity be? Well, it's the reflection of the origin with respect to whatever, line or circle I choose. And so if it's the unit circle or the equator on this sphere, then quoting or reflecting the stopped process would just be the point at infinity. So that would be like at the stopped process. And so from there, I was basically thinking like, okay, well, every process in rhocalc or rholang, they're mutually exclusive constructors on the top level. So everything can be reduced to, it's either a par or it's a send or it's a receive or it's a method or it's a this or it's a that. And so basically all of those different options for processes, you can just split so we're thinking about being on the southern hemisphere of this sphere, basically. And so all of these processes could be thought of as occupying the southern hemisphere in such a way that they basically just subtend a particular angle. So say there's 10 different process constructors and they're all mutually exclusive. Then we can dissect that or partition that southern hemisphere into 10 segments that are all just subtended by some angle that's like 2 pi over 10, basically, so pi over 5. So now we have like a wedge of space that is corresponding to a particular all of the processes that have the same constructor on the top level. So like all sends would go into this particular region, all receives would go into this other region. And then basically all of our names are just created by reflecting those processes. And so if we reflect those processes with respect to this equator, then we can complete this sphere, and this reflection that we talk about in rhocalc or rholang literally becomes reflection with respect to this equator or with respect to this unit circle. But evaluation also is a type of reflection in the sense that I would start with the name and then reflect the name to a process basically by evaluating it.
That's a good analogy. It's sort of like a classical approximation to the distance in the anti-de Sitter space. Calculus.
Yeah.
But 1 over null is undefined.
Yeah. Well, and so one of the interesting things that I'm trying to rectify a little bit is
renormalization.
Yeah. So when we're talking about rholang, we have tuples in rholang, but a tuple can be any process, just put into parentheses essentially. That's if I'm talking about one tuple. So somehow a copy of all of those processes sits within that tuple sector as well. But not only that, because you can have two tuples, so that's like any two processes. So somehow there's also two copies of processes within that wedge, but that extends ad infinitum, right? Because you can have any length tuple you want. And I'm not 100% sure how to visualize that, but there's some really interesting reflective geometry going on there.
Well, it's multidimensional.
Yeah, yeah.
And the thing is, you don't have to, you only expand what you're interested in.
Yeah, right.
Yeah, it sounds a little bit fractal-like once you described it with the tuples that way.
Yeah.
You know, once
So
you have those tuples, you can always send them. So that means whatever's in the tuple section is also in the send section.
yeah, yeah, exactly.
In another
Yeah. So I'm wondering if somehow it's a type of surface that lives above the sphere, in the sense that I don't know if you guys have seen the complex logarithm, but there's a way to visualize complex logarithm, and basically, I'm sure you're all familiar with logarithm for positive real numbers. We can extend that notion to any complex number. Basically, there's a way to represent a complex number where you're representing it by what angle it makes with, like, say like the positive real numbers, and how far away it is from the origin. This is like the polar form of a complex number. And basically, you can take the logarithm. Yeah, that's perfect. That's exactly what I wanted to see. Yeah, great. Thank you for showing that. So yeah, basically, it's just this huge spiral. But you probably remember that the logarithm blows up as it gets closer to the origin. So there's not actually a value defined at the origin. But what it will do is basically it's this huge spiral around, and the distance between those layers is 2 pi basically, because we include the angle into the definition of the complex logarithm, and we know if we start at some particular point, traverse around the origin, and go right back to that particular point, well, we're still talking about the same exact point, but now the angle that we're measuring was the original angle plus this 2 pi that we just used to go around the origin. So there's like another leaf of this logarithmic surface at a distance 2 pi above and below, and then ad infinitum. So I'm wondering if it's similar to something like this, for being able to just have like copies upon copies of the processes, nested into like one of these little wedges. But I don't really know.
When you say for different types of processes, you have different angles, right?
Yeah.
So if you change the types of the parameters of the set, for example, how this affects this angle?
Well, so all I'm saying is any process that at the top level is a send. Now it could have, let's say the name that we're sending on is a method, and the message that we're sending is like a par or something along those lines. That's neither here nor there, because the top level constructor is a send. So that process would be located in just some fixed wedge of the plane, basically.
I'm not sure that I understand fixed wedge.
Yeah.
On this line of sends, of all sends, right?
Yeah. Yeah, so I'm just thinking like all sends will occupy some particular region of space, all receives will occupy some different particular region of space, all lists will occupy some other region of space, and so on and so forth, basically. So you can just like cut out a wedge for each one of these top level constructors, and then so no matter what the shape of the things within the send are, it will still be located in this particular wedge, if that makes sense.
Yeah. So you're not interested really in what is inside the sense of this top level?
Well, I guess that would not currently. I don't know. I mean, sure, yeah, I'm interested in it, but I'm not really sure how to think about it yet. I guess maybe is the most accurate way to say it.
Because you reminded me, now I'm listening about a cubic type theory, and they talk about this kind of structure where you have index type. So you have, as I understand, you have a tuple of types in a sense.
Oh,
So
okay.
You have a type that is indexed by another type.
Mm-hmm.
And from that, you have this spiral of types that somehow is changed. This is you select the first type, and then you selecting others. This other type you are choosing on which level you are. For example, for integer type, for natural number 2 is different type than number 1, but it's also a type.
Okay. Interesting.
So in that sense, do you think about this visualization in that sense, that sand is a type,
Yeah.
and represents you can index other types with this sand, what you choose as a parameter.
Yeah.
But I'm not sure how to look at this function.
I'm not sure either, but I guess I'm thinking about lists or tuples, and I guess maybe it's really easy to kind of extend what you're saying to lists and tuples, just in the sense that a list of length 1 is maybe a particular type, and then a list of length 2 is a different type, and somehow they're related, but not exactly. Yeah, I don't know if that is kind of along the lines of what you're talking about.
Yeah, I'm not sure also how this relates. So yeah, I'm interested to hear whatever you have.
Yeah. Like I said, this was just like a sort of a random crazy thought that I had, and I was like, oh, this is kind of cool. Like I can make some nice pictures from this thought, So I don't know.
But you will show us some pictures, or?
Yeah, I don't have anything drawn nicely right now.
Okay.
I kind of wish I could just like have a sphere and just draw it on the sphere would be kind of cool. Yeah, I'll definitely look into it.
You have to go steal a basketball from a park or something.
Yeah, right. Oh yeah, and they already have the lines drawn on them too.
Yeah.
But is this some kind of mapping that you have from one part of the sphere to the other? I mean, from the inside of the first part to the external part of. I'm not sure how to. This other thing, other.
So I guess for me the most interesting thing was it felt like there was a really natural way to set up this structure so that the reflection, like the quoting operator, was literally reflection in the sphere, and evaluation was again literally reflection, but just from the point at infinity instead of from from the origin.
So what is the equivalent, like in this analogy of the unit circle is the equator? Like what's special about, what do we put at the equator, or what processes live like near the equator versus near the South Pole?
Yeah, sure. Well, so I was thinking it would be like hyperbolic space. So if you look at hyperbolic space model in a disk, I mean, and Escher has some great examples of visualizing hyperbolic space. That entire circle, that entire unit circle, everything on that circle is actually infinitely far away from the origin. And so I was thinking about it like that. There isn't necessarily anything that's living there. You can just approach it, and get closer and closer, but never actually quite make it to that equator.
I I would like to consider the equivalence of general relativity in quantum mechanics in the mapping of space-time,
Yeah.
if anybody's interested.
Oh, that would be cool. Yeah,
I
that's
mean,
so I just got off of the most recent RCast call, and Greg was talking about using some sort of notion of probability distribution from quantum mechanics to model something in with validator incentives, or he was talking about reaction rates of different processes and how they reduce, and being able to use. So he was. He was talking about a lot of different things. So I'm trying to just like keep everything straight. So somebody, I guess, 10 or 15 years ago built this stochastic pi machine where they can actually do modeling of stochastic pi processes. And so he's talking about using that stochastic pi machine to model validator behavior, because everything is just a rolling process in our chain. And somehow the idea of quantization came up, and probability distributions.
well, he was saying that it
know.
doesn't have to be stochastic.
Right.
This
Yeah.
stochastic was a model for it.
Yeah.
Okay.
Yeah.
Now, my understanding. Okay, this is Leonard Suskind's model.
Yeah.
I'm not sure. I just reviewed this article before. I put it in the random channel on the Discord.
Oh, cool.
But I'll just use this diagram. Okay, this unit circle here is actually a black hole, and it's a black hole just by putting a photon into nothing.
Yeah.
Okay, so this is or something. There could be something in there, whatever, and when we perturb the circle, it goes around the circle. But what we have in here is the logical entanglement. And this is where we have the reflection that you're talking about of the logic. And this is, he calls it infinite expansion. He's trying to get people to realize that black holes increase in volume constantly. But that's another thing. But
Jim, what paper is that? That looks super interesting.
yeah, this is. He seems to go over a lot more detail in the video.
Oh, Leonard Susskind. Oh, cool.
Yeah, actually, this is really relevant because I just watched an hour or so lecture of his yesterday about the holographic principle and how how entropy is just hidden degrees of freedom, and the maximum amount of information that can be stored within a space is proportional to the surface area of that space. It was pretty interesting stuff. Oh yeah, could you share that paper with us, or did you say you did?
Well, in the random channel, I have my answer to a question.
Cool.
With
Nice,
that links to the article, but I put it in the chat. I put that in the chat as well.
Awesome, thanks.
There's also another piece that a little while ago we were working with this guy called Marius Bulga, and he has a chemistry view of graph transformation.
Hold on.
And to the extent that the row calculus is all about processes and interactions, I think that might be relevant also. Jim, you have anything to say about that? Or
Yeah. His view is not one of chemistry. His view is of graphic lambda calculus.
Okay.
And the formulation of graphic lambda calculus that he's most interested in is the chem lambda.
Mm.
Okay, chem lambda is a graphical lambda calculus, which he has done amazing stuff with. He's built all kinds of, he's modeled all kinds of algorithms. It's mostly used for modeling chemical systems, but it can be used for a living system modeling. It has in many ways overlaps, with the applications that we envision for the row calculus. Now, the thing that I've said from the beginning, because we've been following Marius's work for a long time, and basically I came from graphical lambda calculus to the row calculus community, is that our base machines, our physical world, our localities are necessarily lambda in nature. And we ultimately implement on some machine. And I'm saying that's where we make the mistake. And that's where I see the hardware, in essence, or the base machine in terms of the graphical lambda calculus, and the control of that machine, the programming of that machine in the row calculus.
So wait, what do you mean by graphical lambda calculus? What does that mean exactly? What's the graphical part?
Yeah, it's not graphical, it's graphic.
Graphic, okay. So what's the graphic part then?
Well, basically, you have a few basic operators, and they're connected. In a graph. Okay. And you have reduction rules that apply to graphs.
Okay. That's what I was expecting. Cool.
So I think there's interest there, and and I mentioned that in last week's debrief. And Greg didn't go into it, but he said, I related something to graphic lambda calculus, and he certainly knows what it is. And
he said something today that probably explains that. What was his quote? Art is long and life is short, or something along those lines.
Jim, I'm not sure if I asked you that. Why do you need something? If you have a rholang on top, why do you need something else on the hardware level? I mean, rholang on the hardware level is a state machine.
It's part of my decentralized strategy. We want everything to be mathematically perfect and simple, but real world things are complicated, and they're built differently from the bottom up and the top down. And you need both to have control from the bottom up and control from the top down in order to have a viable evolutionary system, in my view. It's the way that I want to design governance and art change.
Hey, so do you guys want to think more about that problem you were talking about at the beginning from node testing?
Yeah, I was hoping Chris would join because he said he has an explanation.
Can I show some code real quick to see whether I understand the problem or not?
Oh yeah.
Oh yeah, and before we even get into that, I was wondering if it was has anything to do with sharding, this problem that you guys are talking about.
I believe so. I mean, in the sense that I think decentralization is part of the solution. But that's
Okay.
So if we consider like just this top part of the code here, I was thinking of like, we're looking up some, oh, I did this wrong. So we're looking up some channel or that we're gonna call like final answer. And I did that only because like the question was kind of like, we're trying to observe that something happened, right? Like we want to look into the blockchain and know whether something happened. And then I made a new channel, and this is the one that the COM event happens on. And so like, is deploying this the kind of code you're talking about? Like when can you know that the thing that comes on final answer is the actual real answer?
I'm not sure, and also I'm not sure that he's using registry or yeah, but something that sense.
So like I wondered if we could give just like a minimal example of the problem, or not even minimal, like an example of the problem. Do you have some code?
So wait, would deploying code like that be an issue for the reasons that we were talking about before?
Well, I was gonna say, if you deploy something like this where final answer came from the registry or is otherwise public,
Okay.
then it seems like you should have to wait for finality because anyone else could have sent a different thing on
Oh, yeah, sure. Wait, so this final answer channel, it can have several messages stored on it, right?
Yeah.
Okay.
Good point. Yeah. So Tomislav, do you want to show some code that is more like what you guys were talking about?
I'm searching for the code on the RSong repo.
Oh, cool. Yeah, just look at the actual.
Maybe I can find. Yeah.
So were they running our song on the testnet today?
Sorry?
Were they running our song on the testnet today?
Kevin was showing how to deploy this on the DevNet, but not on the testnet. Yeah. Here's the code. I put it in the chat. And I didn't look in the code into details. So I'm not sure how he waits.
He doesn't listen to our name, and he was getting an error, and that was.
But what is the name exactly? Oh, this is like a global name.
It's a
immersion store.
I don't think it's global. Joshy, can you explain listening on a name?
Well, what code are we looking at?
It's in the chat. But basically, to listen on a name, okay.
So like this one, for example?
Yeah, this contract on the bottom is this name that he's waiting for.
Right, but he's listening for
the immersion retrieving song.
Are we talking about line 7? Or no?
23.
Line 23.
Yeah. Okay, but this rholang isn't being executed. He has Scala that's reading that channel. He's listening on the channel from the Scala code.
What channel?
I don't think this is important. He's just listening on this name and trying to retrieve a song. This on line 23.
This list, the quoted list.
No, he's reading song out.
Yeah. He's reading one by one this song ID in.
Song dat out is what he's reading. Song dat out channel. At the end of the line.
So something outside the blockchain is waiting for data to show up on song data out channel.
Yeah.
Okay. So, Okay, so it looks like, I mean, so this is a contract. This is the channel that the contract is listening on, and so it's a polyadic receive with arity 2. And so I guess when someone calls this thing, then
And this will be
metadata
called
maps
immediately.
somewhere.
If you take a look on
Right. He doesn't want to wait. He doesn't want to wait for the whole song to be read. So he doesn't run the contract, but instead listens in his code for the song data out in real time. So that he doesn't have to wait for it to be completed. I don't know. He doesn't have to. In other words, this code would not be executed.
What code are you saying would not?
Jim, I think that Kevin was telling us that he runs this contract, and he don't wait when user asks for the song data. He prefetch all the data immediately after he deploy all the songs. So in his code, he made deploy or all of the songs in multiple deploys. And then he proposed, and after this propose, he immediately listen on all these names to prefetch all the songs directly from the blockchain.
Right.
And this is the step when he gets empty data on this channel.
Okay, so he initially deploys this code that we're looking at here and proposes it out into a block. Then he deploys a whole bunch of things that call this contract.
Exactly.
With,
I don't think this. I think it's the first one, the storing one. Because first he wants to store, and then this other contract is to receive.
This you're talking about this one?
Up a little further, line 4.
Line 4.
I see what you're saying.
I think this is the one to the save data, and this other one is to get data.
Okay.
Mm-hmm.
Yeah.
So what's the question now?
So after he deploy all this, after he send all of these deploys to the validator with all of this storing, he immediately proposing it. He immediately want to retrieve.
Okay. And he wants to retrieve it from the same validator to which he proposed it, or just from some different other validator?
From the same one.
Okay.
And on the DevNet, that was a problem.
Yeah, and so the suggestion is it's because that validator is not going to give you anything back until it's certain that it's finalized?
Well, we mentioned what can be the problem, but yeah.
I see.
We didn't have a conclusion. But yeah, Chris was saying that you should get the data after you propose it. So that was strange for me,
You were saying that seems dangerous in general because that data, because whatever the node told you might ultimately not be what was finalized. Yeah, I mean, I definitely am not qualified to answer like what the specific bug with this contract on that implementation of rholang was. But yeah, I think that is an interesting question. Like, when should a node tell you whether something is on the channel or not? Yeah. And I was thinking about it a little bit, like one of the things I was getting at with this code was that this is like a new name here. So this would require like a super smart compiler or interpreter or whatever, but in theory it should be possible to reason from the code that the scope of Chan is only these lines that I've highlighted. And once this code has been executed, the state of Chan will never change again because no one has a reference to it anymore. But yeah, I definitely don't think that's implemented right now.
I see. I like your example because now you have a registry. And what is the final answer, right?
Yeah.
because you could send the same deploy to other validator and send not 5 but 10.
That's why I typed this down here. Yeah.
So I think that your example is more general and better describe this problem.
Right. So if we send these to 2 different validators, then I think the question of what's on Chan, this one, is settled immediately upon deployment because that name is not in scope anywhere else. And likewise, what's on Chan, this one, the answer is 4, settled immediately. But the question about like what's on final answer, that's a public channel that can still change and be mutated and things like that. And so we need to talk about finality when we're talking about that channel. That was sort of like my intuition.
Yeah, exactly. Yeah. So the question is, do you need this final answer? Do you need this value which is not finalized? What does it mean to have this value? Is that
this you're saying final answer?
Yeah. If you exactly want to see what is in the final answer.
Yeah, well, I think the most important aspect of this final answer variable is that it's a public name. Anyone can use it. In this case, it's public because it's in the registry. And in Kevin's case, well, we don't really know what song data out is because it got passed in from somewhere. Oh, which means it's someone still has scope to it. So
yeah, you're directly sending this song data out. So when you call with gRPC, you're saying, get this data to me.
Yeah. So I think song data out is different from Chan in my example because we don't know where the scope of song data out extends to. It could be, still the caller could be mutating it or reading it or whatever.
Yeah, so and really anybody has access to it, right? If they just call this contract with whatever channel they want there for song data out.
Oh yeah. Oh well, but then it's the question of like, is that the same song data out that Kvan's listening on?
Yeah. Well, okay. Right.
Yeah, that's an interesting question.
Hmm.
So what was Chris saying about it?
What I understand from Chris' comment that you should get the value although it's not finalized.
Yeah.
So but he didn't have time to explain. So I'm wondering about that.
Yeah, gotcha. Cool.
So pretty unrelated, but I got something kind of cool working in my implementation yesterday. I think I finalized it. But I got string interpolation working, which was like way more complicated than I was originally expecting, because it's like totally crazy. So I originally tried to do it on Tuesday, and I think it was just a crude approximation of the solution. And then, improved it a lot yesterday, because basically what I was thinking was, with string interpolation, right, the way that you indicate what you want the key to be is you put the $sign in the curly braces, right? But that string could have other $signs and curly braces in it. So how do you tell it the right place to look, and so originally I would basically find the first occurrence of the $sign open curly brace. Now, whatever comes afterwards before, a closed curly brace, like that's what I actually want. But in the first version, I found the $sign open curly brace, then just looked for the first occurrence of a closed curly brace. But that's not right, because if you have a closed curly brace appearing before the $sign open curly brace, like you have all sorts of issues, because now you're asking for substrings of later position to earlier position, so you're taking exactly the wrong stuff. But I've corrected it since then. But it's just like totally crazy. It took like 50 lines of code to do it. I mean, it's so ridiculous. And that's using built-in functions in K, because they have all of these string operations and stuff as well. But yeah, it's kind of cool. It's working perfectly fine now. Like I actually have, my the rholang maps that are, like the JSON objects basically, with strings, and it'll interpret it correctly. And your maps can be whatever you want them to be, but as long as the thing you want to substitute for actually maps or actually matches one of the keys, then it'll go through.
Cool.
Yeah.
And can you nest inside the string another substitution?
Oh wow. What do you mean by another substitution? Like multiple substitutions?
I mean, inside the string you have substitution, and inside this substitution, you can express any code, right? Oh no, you must say what's the key, right?
Yeah. And strictly strings. Yeah.
We might be able to make an interesting example, though. I think that was a good question. So we could do something like, hello, and then like, what's the syntax? It's like this, right?
Yeah, exactly.
And then we need a map here where it's like
Right.
name maps to Isaac.
Yep.
So that's working, right? And
oh yeah, and you can even make that map can be as complicated as you want, as long as it has even if it doesn't have a matching key in it to do a substitution, it'll just return the original string. But as long as it has one key that matches what you want to substitute for, it will do the substitution. Yeah, and that's exactly what it should do.
Nice. Okay, here's my next question. So we agree that reduction happens the way we had up there.
Yeah.
So what if we do this now? What we substitute in there is like this string.
I have to warn you that this there's another governance meeting starting here to review governance documents.
Okay. Yeah, we'll nix it.
Cool.
I think you need to put it inside the curly braces after Isaac, right?
Oh, that would work, but that's actually not what I intended. I intended this one to reduce, and as part of the substitution, we're left with this.
Oh, nice.
And then we do another substitution.
Yeah. So currently the way that it the only thing that will go through, the only thing that will type check is if the key and value are both strings.
Yeah. Oh, yeah. Right.
So yeah,
I think we're good in this case, though.
So your right side is not a string as written.
This one?
Wait a second.
yes.
But hold on. Oh, yeah, definitely. Yeah, that should work as well. I didn't test it, but it should.
Oh, cool.
Actually,
Dude,
we
that's
can,
great.
let's go ahead and test it, right? Why not?
Yeah. Jim's saying he's got another meeting here now, though, right?
Oh, right. Yeah, it's noon already.
Cool. It would be fun to test that in our node, too.
Oh, yeah, right. I also did not do that. I just, had an idea of what the string interpolation was supposed to do from examples I've seen you done.
Yeah. Cool.
Yeah. Nice.
All right.
This is something. Before you go, I just want to show you. This is something we could test by going on two different testnet nodes. We have a get ticket contract, which just initializes ticket to 0 and then increments it each time, so that when we call it, we get ticket number 1, ticket number 2. Now, if we all get a ticket at the same time from different nodes on testnet, we should all get ticket number 1 is the question, and we're waiting for Crispy to explain why that wouldn't happen.
Yeah, gotcha.
Okay, I'm gonna stop the recording and restart.
All right, I'm gonna bounce out. Good to see you guys.
Yeah, I'm gonna take off
Yeah.
too.
Bye
See you
bye.
later, guys.
See you.